Okay, so in this first topic, divisibility rules for 2, 5, and 10, you're probably familiar with them already. And maybe not though, and either way is fine. So a number is divisible by 2 if it's even. So 4,926. It's even. The last digit is an even number, so yeah, it is divisible by 2. 2 will divide evenly into that number. Okay, so you just look at that. Look at the digit in the ones place, the last digit, and if it's even, 2 divides in. So that's the rule that you do for that. Now, a number is divisible by 5. Well, let's go 10. By 10, if the last number is a 0. So if the last number is a 0, then that means it's going to be divisible by 10 because, well, there's a, I'm not going to go into it, but I can if you want me to later on. Just email me. So that's the test for divisibility by 10. Okay. Just check that last digit, see if it's a 0. Now it's divisible by 5 if the last digit is a 0 or a 5. Either one. Either one will work. And that kind of makes sense. You're like, yeah, okay, I see that 25 there and 5 goes into it. Or I see the 20 and 5 goes into it. So those are the divisibility rules. Okay. So let's see what we got here. So which numbers are divisible by 10? Well, this doesn't end in a 0. So nope. Doesn't end in a 0. Nope. Doesn't end in a 0. Nope. So I'm going to say none of these. Okay. Which of these are divisible by 2? It's not an even number. So nope. This one is even. The last digit is an even number. It's a 2. This is not an even number. So nope. And which numbers are divisible by 5? Okay, the last digit in the ones place is a 5 or 0. So yep. But here that's not the case, and here that's not the case. So that would be how you would do that one. All right, so for this one, we're seeing if 3 and 9 divide in. Okay, now the rules here for 3 and 9 are they're a little different. That's why it's just a different topic. It just kind of did it separately. But the rule for 3 and the rule for 9 are pretty similar. So here's how it goes. So if I have something like 8,675,309. 8,675,309. Then, and I say, all right, is it divisible by 3? Well, to know, you add all the digits. You say, all right, 8 plus 6 plus 7 plus 5 plus 3 plus 0 plus 9. Okay, so what do we get? We got 12, 24, 34, and 4 is 38. Okay, does 9 divide, and then you do, so, oh, I'm sorry, okay. So then, to see if 3 is divisible, you add all the digits up, and then you look at that sum and you say, does 3 divide into this number? No, it doesn't. So 3 does not divide into the original number. So you just add up the digits, look at that sum, and say, does 3 divide into that? If it does, then 3 will divide into the original number. And if it does not, then 3 will not divide into the original number. Now for 9, you do just about the same thing. You add up all the digits, and then you look at the sum, and you say, does 9 divide into this? If not, then it doesn't divide into the original number, which is the case on this one. But if it did divide into it, if it had divided into it, then it would divide into the original number. So that's kind of the idea. So let's see what we got here. 632. Let's see, if we add these digits up, we get 11. Does 9 divide into 11? No. Does 3 divide into 11? No. Okay, moving on. 201. Add those digits up. 2 plus 0 plus 1 is 3. Does 9 divide into 3? No. Does 3 divide into 3? Yes. So again, on this one, the answer is no, because 9 does not divide evenly into 3. Oh yeah, sure, 3 divides into 9, but that's not what we're checking. We're checking this one. How about this? 1 plus 8 plus 3 is I don't know, it'd be 12. 12. Does 9 divide into 12? No. Does 3 divide into 12? Yes. So for the 9, the answer is none of these. Okay. But if this had been 187 instead of 183, 1 plus 8 plus 7 would be, oh, wait a minute. That still wouldn't work. Let's see, it'd be 15, 16. I need 2 more. Okay, so if it was 387, that's getting hard to read, sorry. If it was 387, the digits would add up to 18, and then 9 would divide into that. Okay, but anyway, that's how it goes. Okay, so write all the factors of 35. Okay, first of all, there are a couple of words that have a tendency to get used interchangeably in math. They are factors. That was really weird. I just got the new version of Zoom downloaded, and this is the first time I'm using the new version, so I don't know why that box appeared. I'm going to try that again. Maybe. Okay. I don't know. Okay. And the other word is terms. Okay. Factors are things that are multiplied together. Terms are things that are added together. So for example, if I said 3 times 4 plus 5. Okay, well, these two guys are terms because they're added together. Within this first term are 2 factors because they're being multiplied together. All right. So a lot of people that just use them interchangeably, but if you make sure you use the correct word for the correct situation, it does tend to help your understanding of what's going on. Okay, so when they say write all the factors of 35, they mean the numbers that multiply together to give 35. So the way I like to do it is I like to do a factor tree. Okay, plus I like eating fruit off of trees. I've got a peach tree and a couple of cherry trees. I didn't need the second cherry tree, but my neighbors, they cut theirs down when they moved in. So the bees couldn't pollinate mine anymore because you had to have 2 of them close enough. So I'm growing another one. It's getting there, but it's not real big yet. Okay. So then we say, all right, what's something that divides into 35? Now, don't pick 1 because that is not helpful. And don't pick 35. Okay, so don't ever pick 1 or the number itself. It's just not helpful. It's true, those numbers do divide into 35. So you might say, well, hey, after that, those divisibility things, this number ends in a 5, so I know 5 divides into it. So I'd say, all right, how many times does 5 divide into 35? And you'd say it's 7. So you end up with a couple of numbers here that multiply to this. All right, now, is 5 a prime number? Well, that's actually going to be our next topic in this video. But yeah, 5 is a prime number because there's nothing that divides into this guy except itself and 1. So I'm going to put a little circle there. That's not necessarily standard when you look this up on YouTube, but so there, I have a piece of fruit now. Look at that on my tree. All right, now how about this guy? Is this guy prime? Is there something we could divide into 7 besides 1 in itself? No, there's nothing. It's only divisible by 1 in itself. So that's a piece of fruit, and that's it. Okay, there's no other branch over here that we can expand on. So so the prime factorization of 35 is 5 times 7, or 5.7. Okay, and the dot means multiplication. So I'm thinking maybe another one would be super cool. Okay, so on this one, got 20. We say, all right, what's something that divides into 20? Well, you might say, hey, I just happen to know that 4 divides in. How many times? 5 times. Okay. All right, so is 4 prime? Is there anything that divides into 4 besides 1 and 4? Yeah, there is. Oh, okay. So we can break 4 down further. But 5 we just saw is prime. There's nothing that divides into it besides 1 and 5. Well, what divides into 4? Well, it's an even number, so 2 divides in. How many times? 2 times. And 2 is a prime number. In fact, it's the only even prime number. There's nothing that divides into it besides 1 and 2. So we get fruit for both of those. So that tells us that 20 is 2 times 2 times 5. Or if you want, you could write 2 squared times 5. And that'd be fine too. They're both fine. Although practicing using exponents is a good thing. So you just look at all the fruit, all the prime numbers, and that's going to be what you get for your prime factorization of the number. Okay, now you might have said, whoa, not so fast, Mr. Borman. When you started this problem, I was thinking to myself, hey, the last digit is a 0. 10 divides into this. Okay, cool. So 10 divides into 20 2 times. We know that 2 is a prime, so we get a piece of fruit there. But 10, is 10 prime? Is there anything we can divide into 10 besides 1 and 10? Yeah, it's even, so 2 divides in. 2 divides in 5 times, and we know that 2 and 5 are both prime numbers. Hey, look at that. We get a couple of 2s and a 5, just like we did last time. So yeah, so that's okay. That's there's nothing wrong with doing it that way as well. Okay. And that's the factor tree. There's also the elevator for factoring instead of the tree, and I can show you that if you like. Or if you have your own way of doing it that's different from mine, that's fine. I don't care. I just, got to show you something. So, all right, let's go on to the last topic. Okay, so here we go. So again, which numbers are prime and which are not? So obviously 1 divides into 2 and 2 divides into 2. Let's make that a little bigger. Yeah, we can make it still bigger. Anything else? Well, you only look at numbers that are between 1 and the number itself. And we already excluded 1 and 2, so that's it. So that's prime. How about 7? We just saw in our video a moment ago that, yeah, 7's prime because nothing divides into it. I mean, there's 1 doesn't count, 7 doesn't count, and that just leaves you 2, 3, 4, 5, and 6, and none of them divide into 7. So yeah. How about 8? Uh-oh. 2 divides into 8. So does 4. So that's something that's not 1 or 8. Therefore, it's not prime. It's called composite, which isn't really important to remember. 19. Okay, 1 and 19 don't count, but we got to check everything from 2 on up to 18. And it turns out none of those numbers divide into 19. 2 doesn't, 3 doesn't, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Well, 19 does. 27, yeah, 3 does. Add the digits together and you get 2 plus 7 is 9. 3 divides into 9, so 3 divides into 27. 29, that one's prime also. Nothing divides into that except 1 and 9, or 1 and 29. So, and you can, take your time, use those divisibility rules, pull out your calculator, and just, start typing things in. Like for the 19, maybe you're going to maybe be like, okay, 19 divided by 2. Nope, it didn't divide evenly because there's a decimal. 19 divided by 3. Well, we already know that because 1 plus 9 is 10, and 3 doesn't divide into 10. 19 divided by 4. Nope. 19 divided by 5. We already know that doesn't work because the last digit in 19 is not 0 or 5. And you can just check it all the way up. Okay. And as you get more familiar with this stuff, it makes it easier. And again, like I keep saying, all these things are going to make life easier throughout the rest of this class, but particularly your algebra classes that follow this class. Okay.